Well, hi, I'm Barbara Dill, and this is my shop. This is the chapter 2 in my set of videos that I'm making since I've retired from traveling and teaching. I hope you enjoy it. I wanted to give you a quick tour of my shop. It's a rather large building, and I've appreciated the space I've had because I can spread out and do a lot of different things and see the ideas that I have created, so that when I wake up in the morning wondering, I wonder if I could do that on 3 or 4 axes, at least I have those pieces around. Here on this shelf are some of the pieces I turned in the 90s, where all I did was randomly change the axis, and I didn't know what to do after that, so I got frustrated. But a lot of this is my earlier work, some of my first bowls up there from my first class with Michael Hasseluk, more studies and experiments that I keep down here so that I can see what I've done and think about where I might want to focus some attention. So I just wanted to give you a quick overview of this area that I love so dearly. So in the first video, we talked about the fact that there are 2 types of axis placement, either parallel or twisted, and then under that come a lot of variations, but 2 basic types of axis placement that are relative to that center axis, or any line parallel to that center axis. And I also talked about there are only 2 outcomes that happen when you change the axis. Either you go through the airwood, I explained what airwood is, and cut a cove and a bead and a cove in the airwood, put it on another axis and make some more profiles, and those profiles intersect, those arcs of the profile intersect, making a outcome that's not round, it's arc type. And then the round circular type outcome happens when you cut all the way through the airwood and get to the solid core, that's the solid wood between the headstock and the tailstock, and then make a profile and then change the axis and do more. So that means that there are only 2 types of axes, 2 types of outcomes. So now if we make a table and we have the parallel axis on the top, twisted axes on the bottom 2 quadrants, arc type on the left and circular type on the right, we have 4 families of spindles that have 2 things in common: axis placement and type of outcome. So that was all discussed in the first video. This video is about the variables of this conceptual model of multi-axis spindle turning. So we've gone over the types of axes, the types of outcomes, and how that all fits together. But now what? Now there are all these variables, and each one of these variables can apply to each one of those quadrants. Each quadrant is made up of just one type of profile, one type of outcome, and one type of axis. But all of these variables fit into all of those. So this is where all the magic begins. This is why I think this is important information, because if you take the time to understand how all of it works together, you can create forms that are magical that you hadn't even thought about, just by playing with the variables, sort of like in music and notes and music theory. I'm sure a lot of people wonder, why would I spend so much time on this one area of turning? For one reason, I was fascinated with it. But one of the major things that happened early on in the 90s is that there was a belief in the wood turning community, as there are in most art forms, I'm sure, that if you did a type of work, you were copying somebody else. And so what I didn't want to do was copy anybody else doing multi-axis work. The only way not to copy them was to understand more about what I could do next. And that's what motivated me to come out here and isolate myself and really take a close look at these spindles and see what they had in common. The topic of copying other people's work is still a hot topic today, and there's not a whole lot of agreement on it, but I certainly have my own opinion. And my opinion is this, that if I teach something, it's yours to have and use and make. Hopefully you will use the information to not only make what maybe I showed you how to make, but then make something from that idea that might be more yours. But anyhow, I don't own a three-sided twisted anything. It's not a signature piece. In April of 2013, Betty Scarpino published an article written by Jerry Bennett, and it addresses this issue. It's called It's Mine, Mine, Mine. And they talk about some really important points that I think are really very interesting, and we all should think about them. There's a very important difference between a concept and a signature piece. So let's go into it. Because I was a nurse, I look at a spindle like this one. I hope you can see it. And I say, well, it has three elements. It has the size and the shape of the wood. It has an axis, and in this case it's the center axis, and it has a profile. So under those three major categories fall most of the variables that will apply to each spindle or part of a spindle that you turn. Let's take the size and the shape of the wood. It matters if it's long and skinny or short and fat. If you turn the very same idea on it, the outcome, the design will be really different, and I'll show you that in a minute. The axis placement. I've talked about how there are two major types of axis placement, either parallel relative to the center axis or not parallel relative to that center axis, or any line parallel to the center axis. So that means there are millions of opportunities to place a new point on each end and create a new axis. They can be equal degrees apart, they can be closer to the outside of the spindle, closer to the inside of the spindle. There can be one on one side and many on the other. The options are enormous. So all of those give you a lot of ideas to play with about an idea that you're turning. And then the third very important variable is the profile. And I break the profile into just simply a bead, a cove, and a V-cut, and a straight line. So those elements can either be symmetrical or asymmetrical. And also the depth of cut makes a big difference as to the outcome of what you're turning. So in a nutshell, those are the variables. That's what we'll be talking about now. So here are just a few examples of axis placement and types of outcomes. On this spindle, I've scribed three axes that are separated by 120 degrees, and since I knew it was going to be arc type, the axes could be closer to the outside of the spindle. I've numbered everything on the outside 1 to 1, 2 to 2, 2 to 2, and 3 to 3. And so this is going to be parallel axes, so I know that I can put it. I know the headstock is here because I have a 4-prong drive at the headstock. So now I can reliably put this on my lathe between centers and know that this one of these axes is going to be the one. So that's the axis that has that cove cut in it. And as I changed it, that was 1 to 1. I would go in a systematic way, 2 to 2 and 3 to 3, to create the other axes. The depth of cut, you can, it's important to have the depth of cut be what you want it to be. It doesn't have to be the same. These can certainly be asymmetrical. The cove can certainly be asymmetrical. Here's the second axis right here. Once again, there's a cove. If I leave the tool rest in the same place, I can measure the depth of each cove, especially on a twisted or parallel axis, and make sure that that is the same depth if you want symmetry. So that's an example of 3 axes separated at 120 degrees, getting ready to be turned as arc type because the axes are closer to the outside of the spindle. Here is an example, another example of that same idea. These are arc type, but they're alternating coves on 2 axes that are in the same plane of the center axis. And the axes can be towards the outside of the spindle because, once again, I'm not going to try to find the solid wood as in a circular type, but I'll turn alternating beads. And this form becomes really important because then you can do that on 3 axes, 4 axes, and you can do them on twisted axes, and they can evolve into something. Here's one on 3 twisted axes. They can evolve into a lot of interesting forms. Now going back to our quadrants, this spindle here was turned on the center axis. One of the spheres was turned on the center axis. That one was turned on the center axis. And then to show what a twisted circular is like, I think I left that one there and I offset this one. I might have been showing somebody how it all works, and now that's not on it either, so I must have put that down there. Let's see if that's it. And there's the twisted circular type, and you can see that the one that was on the center axis is now out of sync. I had to cut through the air wood in order to create the solid wood, and I wanted to create a sphere on that. I wanted a lot of solid wood, so the axes on this are closer to the center axis. And I did this as a fast demo, so I'm not sure exactly. I didn't mark everything, so that's 2. I don't even think they're in the same plane. No, they're not. So a twisted axis doesn't have to be in the same plane as the center axis. But that's just to show you how the axes need to be closer to the inside of the center so you can grasp more solid wood in order to create a fatter profile. And here is another example of twisted axes on 3 axes separated by 120 degrees. The numbering's the same, 1 to 1, 2 to 2, and 3 to 3, and I number them on the outside so I can see them. The axes are placed a little more than halfway from the center of the spindle. And my systematic way of numbering is I always go from the headstock end, the smallest number. So let's just randomly put this on 2, and we'll put the headstock on 3, the tailstock on 3, and then we'll see if that's not correct. So that's right for that axis there. So not only do I have a pretty cool piece of wood that I've turned, but now I know how to replicate it. I know how I did it, and all my notes are on that piece of wood. I used to write notes on pieces of paper, and after I turned them, I had no idea what I meant. So now you can make these spindles in all the quadrants. This information replaces the random switching of the axis, which is what I did in the 90s, just randomly switch the axis and try to see what happened, with actually thinking about, oh, I can do that on 2 parallel axes. What would happen if I did it on 3? What would happen if I twisted it? What would happen if I used a larger piece of wood? So now, when I figured this out, I would wake up saying, oh, what would happen if I did this or that, and we'll come out here and play. So it gives all sorts of fun ideas that you can play with on the lathe. I'm going to go ahead and show you some ideas that happen in each family and how everything changes when you change the size and shape of the wood or the axis placement. So how all these variables can come together. I haven't done a whole lot of parallel axes. I've done a lot of twisted axes when I've played around, but it's certainly the same idea you can do on parallel axes. I just seem to like the twisted axes more. But within that first quadrant lies split turnings, and you can put 4 pieces of wood together and glue them up, wrap them with tape, and then rotate them either 2 or 4 times in order to create a form that you can either separate and have each one of these be whatever you want it to be, or you can then do an inside-out turning with that and glue them all up and create inside-out turnings. So all of these ideas fall in quadrant 1. Anything you can do on a parallel axis between the headstock and the tailstock, you can do as a split turning. So now let's go into this idea of alternating coves and alternating beads. This is alternating beads on 2 axes that are in the same plane as the center axis. they are archetypes, so the axes can be closer to the outside. And on one axis, I turned these beads, and then I turned it around and alternating, the middle of the V-cut is on the top of that bead. So I alternated beads and did that. And I did that a long time ago on a small piece of wood. And it took me many years to think, oh, I wonder what would happen if I twisted that, or if I did that on 3 axes that are parallel. So these axes are once again sort of closer to the outside, but I have 3 alternating beads. So that means on each axis, I advanced each bead by 1/3 since I have 3 axes on it. So I said, that's cool. And then this evolved into doing it on 4 parallel axes. And then I started doing them on twisted axes. This one is 3 archetype beads on 3 twisted axes. And you can see how much fun you get into when you start doing, oh, look at that, that's pretty cool. Let me just put that, this is archetype and twisted, so that should be 3 to 1. Let's just see what that looks like. And sure enough, you can see those beads on that axis. So that shows why a systematic numbering system is convenient, because now I can show you the axes and how it all works. So from these small spindles grew a large body of work that I'll show you right now. You know, I mentioned before that everything in parallel archetype in that quadrant can be done as a split turning. Well, here is a sculpture that is one of 4 that was done as a split turning, putting 4 larger pieces of wood together. Now, the reason I like split turnings is that you can turn on a lathe heavier, larger pieces of wood, and it's balanced, and then you get 4 instead of 1 for your effort. So this was rotated 4 times. Each bead was advanced by 1/4 since there are 4 axes on it. So that's pretty spectacular, I think. It was a lot of fun to make anyhow. And here's some images of the very first split turnings that I did. I learned a lot from them, and I'll probably get into it in another video. Here's some smaller pieces. This one is 3 axes on a stockier piece of wood of holly, and 3 axes alternating beads, and the beads alternated by 1/3 on each axis. And in the same vein, you can do this idea, alternating coves on 2 parallel axes. Once again, these are all archetype, so the axes can be closer to the outside of the spindle. And from that, you can use larger pieces of wood, twist the axes on 3 axes, and come up with a sculpture like this. And it's actually a screw form, because if you measure it correctly, this edge swirls all the way up to the top. So if you put enough axes on them and measure them right, you could actually make a wooden screw, an accurate wooden screw. So this is a shorter piece of wood than the smaller ones that I was working with. So these are all archetype. A discovery I made years later is that a screw form can be turned on a parallel as well as a twisted axis. These alternating beads quickly became circular when the depth of cut was too much, and I grabbed the cylinder. So here are alternating beads on 3 axes separated by 120 degrees and twisted at 120. Here are alternating beads that are on 3 axes. So I just cut too deeply and it became a whole different idea, more like clamshells or whatever this sculpture means to you visually. So that was a lot of fun to discover that. But when alternating beads were fatter and shorter, I call this spheres interrupted, because on one axis, well, first I did this bead and these halves of a bead, and then at 90 degrees I twisted it and I did this bead and that bead. So this is a whole nother form and just what evolves when you know how to play with things and start playing with axes and circular outcomes and twisted outcomes. I grabbed a few videos from my files to show you the process of this. This one is the first axis, this one is the second axis, and then the next video shows it as it's finished. That's why I call it Spheres Interrupted. So now let's go on to the twisted axes. This is my favorite form. In fact, my most beautiful one is right here. I just love this walnut one. The cuts were deeper. It's a more graceful, symmetrical coves on each end. It's twisted at 120 degrees. And I used it a lot for goblet stems on goblets. You can tell the difference if the cuts aren't quite as deep, it's not quite as elegant, but these are my favorite form, and they're not owned by anybody. They're just what happens when you twist some axes and create a 3 or 4 or 2-sided form. From that, I started making these cups. They are also twisted at 120 degrees because, and I put a tenon on each end so that I can not have the point interfere with the actual lip of this cup. So I have a tenon, and I go from 1 to 2, 2 to 3, and 3 to 1. And like I said, because they're arc type, the axes can be on the outside. And once I've developed these ideas, and I can take a popsicle stick and measure the depth of each cut from the tool rest, since I don't need to turn the tool rest, and then I can put it on a 4-jaw chuck and hollow it out. But these are really nice forms. You don't have to twist them at 120 degrees. On my longer candle holder forms, I have twisted them less, and I'll show you that. I really enjoy making these longer twisted candle holders. I decided aesthetically for me, I didn't want the twist to be 120 degrees from the top to bottom. So this twist is probably about 60 degrees. And I put lead in the bottom and fill it with wood glue. But I really love the form. It's about 1/3 down. The asymmetrical cove is smallest at about 1/3 down. And then I make these inserts from copper end pipes that you can get at a hardware store. So this is a really nice candlestick. Here's one that is made out of holly, and then I carved it, so it's got lead in the bottom as well. And then here's one. Oh, and the numbering system I use when I don't twist it 120 degrees, I had to redo my numbering system. Instead of going from 1 to 2, I had to renumber this 1 where the 60-degree mark was. So I'd go 1 to 1, 2 to 2, and 3 to 3. Well, that works if you remember it. And on this candlestick, I forgot it, and now the twist in the center is extreme. It's probably 160, or who knows, the twist in the middle, if you can see that. I don't know if you can see it. It's an extreme twist. So I discovered how to make an extreme twist when I didn't really want to, but it's okay. It's all right. That's what happens. This is a candle holder that I turned one winter, and I wanted a 90-degree twist, but an off-center element in it. So I turned that, and I realized that this twist is more like 30 degrees. It's not 90 degrees. The twist from the top to the bottom was 90 degrees, but the twist in that segment was a lot less, which made me think, okay, I like that. Let me see if I can turn an element like this with a 90-degree twist. They're coves, opposite coves, twisted at 90 degrees. So I did. I made several objects. I call them the wave. You can make the twist more or less, but this is more like a squarish piece of wood rather than a long piece of wood. Now, so far I've talked mostly about arc-type spindles that I've turned. I seem to really prefer arc-type to circular type. Now I'm going to go into one form that I like that has circular type in the middle on an off axis, and then it has 3 axes on each end, and on the bottom end they're twisted to my right, and the top end they're twisted to my left. just to see how that form would look. And I really like it. So circular type, you go all the way through the air wood and create that form, and then I'm able to create all of those other arcs on it. So that's fun. There are a lot of fun things you can do. You can mix circular type and arc type. So we've talked about alternating coves on 2 axes, arc type. What about circular type? So I had done some smaller spindles years ago. Well, I can't find it now. And I wasn't impressed with what I had made. Here, now, anyhow. Oh, here it is. So I had done that as a circular type of experiment. But I thought, well, it's long and skinny. It's not very exciting. So I didn't get back to that idea for quite a while. Then I started playing around with coves on a circular type spindle, and started playing with, what if I put one axis on one end and many on the others, and kicked it out and made a curve that even a chiropractor would love, maybe, to work with. And started experimenting with the number of axes I could put on the end. This one also has 1 axis on one side. So I have a whole box of them here. I just got crazy. Some people say I got obsessed, and I think they're correct. Here's one that has many on each end. I was trying to see how much of a kick out and a curve I could get on each end. So sometimes I'd have one in the center and one on an off axis and the other, and then the headstock on the center while the tailstock was an off axis. Just trying to play with it and see how many curves I could get. So I made multiples of these, but the end result was that first I made goblets the way I used to when I first started, and that is, I made a cup with a tenon on it. I made a spindle stem, and then I made a base, and I mortise and tendoned them together to make goblets. Well, I like that method because I could make a thinner handle or stem on a goblet, and it was more graceful, so I enjoyed doing that. But it limited me, and I wanted to see if I could do it with one piece of wood. So I was able to do this goblet using one piece of wood and hollowing it out, putting it on a 4-jaw chuck, and then throwing it off. And as that went around, grasping each axis, and I think there are 4, it spirals with 4 axes. And I was able to get a really cool spiral on that. So I was happy to do it either way. I also made a candle holder using that same idea, just a nice spiral. I had 4 on that end and 1 on this end. And so it was just a lot of fun to play with. The sky's the limit. It's up to all of us to see how we can develop these ideas and what to do with them. As a side note to the way I've been making art through turning wood, years ago I was invited to be at a show that the AAW sponsored called Harmony. So I'm not a conceptual turner. I'm looking for form. I see the beauty in the wood. I don't like to name my pieces because I think that everybody who sees them might have a different feeling or take on what they are. But all my friends said, oh yeah, you've been invited, you should do this. So all fall that year, I tried to create something called balance or harmony. And I thought, shoot, that'll be easy. I was raised in a fundamentalist church in Tennessee. We did do, re, mi's. My dad was a song leader. I'll just turn those symbols, do, re, mi. And that was impossible. It was ugly and I didn't get anywhere. And just when I was ready to give up the idea, I saw one of my earlier pieces in my window, and it's a piece that I had turned even before I understood the ins and outs of how to think about multi-axis spindles. So I wanted to show you how harmony evolved. Years ago, before 2006, when I figured out this systematic way to think, I had just randomly turned a form like this and thought it was great. So I ended up making a whole set of candle holders by refining that form. So I still have some of these left. And these are the pieces that I made that led to the creation of Harmony. I just had to learn how to put it in a 6-inch cube. So I think what I'm talking about is the way I create what I've created. It's more of a systematic and a scientific way to think about things rather than drawing an idea out and saying, oh, I'm going to make that. I've been chasing forms and what can be done between the headstock and the tailstock on a lathe. And I get obsessed by seeing how many axes I can use on some things or seeing what I can make. So it's a whole different method of making art. I was honored last year to have a featured article written about me in the American Woodturner. As Dee Wood had interviewed me, I mentioned that I had a musical background, that my father was a professional musician and played his lovely silver cornet all through his life, even though after the war and the Navy, he became an optometrist instead of a band leader, but he always played music. So music is really a part of growing up, and I took trumpet lessons back in the 50s and the 60s, and part of that was learning variations on a theme from things like Carnival of Venice. So when I do this kind of work, I think about variations on a theme, and this is what is in my head when I'm going from a very simple small spindle and then making it have 3 axes and 4 and making it larger. So I always think about this piece of music. So that's why I wanted to just show you what variations on a theme sounds like on a trumpet. It would have sounded better back in the 50s when I was better at it, in the 60s. But I'm going to give it a shot now. And if you want to hear somebody really good play it, go to YouTube and Google or find on YouTube Winston Marsalis variations on a theme with a lot of things, including Carnival of Venice. And a variation on a theme is common in music. Variations are common in just about every other area of life, but I'm more familiar with music. When a theme is varied, there's a theme, and then you can vary it by changing the rhythm, changing the key signature, adding a lot of notes, adding many things, but the basic theme is still there. So that's what a variation on a theme is. And on, which I'm not going to embarrass myself to continue playing that. So, in summary, these first 2 videos that I've created summarize the essence of a way to understand multi-axis spindle turning. I think it's the pathway for people to be a lot more creative and discover a lot of very interesting forms and have a lot of fun along the way. In the future, I'm going to enjoy now just being in my shop and creating some of those things or videoing the way I make them, so that might help you understand the mechanics of all of this even more. Feel free to leave a comment on my YouTube station, or email me or contact me if you have any ideas about what you would like to see me make. So, thank you.